Hello everyone, I'm Mighty, your hands-on practice assistant. In this session, we'll go through a CFD simulation together step by step and follow along with the practice example. The topic of today's practice example is vehicle aerodynamic analysis. We will take some time to learn one of the most fundamental CFD simulations, external flow analysis. What is vehicle aerodynamic analysis? It is a numerical simulation used to calculate how airflow affects a vehicle while it is moving. After the simulation, you will be able to review results such as the airflow behavior around the vehicle, as shown here. Before we begin today's practice, let's first summarize what we will be covering. Today's example will proceed based on the summarized content shown here. After briefly reviewing the analysis model and boundary conditions, shall we begin following along together? First, after running NFX, click New button in the upper left corner to create a project. Then verify the unit system and click OK. Now, let's import the model. Click Import in the Geometry tab to open the CAD file. Once the model is loaded, right-click in the workspace and select Hide All Guides. If you look at the model tree on the left, you can see two models, the vehicle model and the air domain model. In general CFD analysis, you usually need to extract the fluid domain separately. However, for convenience, I have already prepared it for you this time. Now, shall we move on to material and property settings? For CFD simulations, fluid and solid material data must be selected from the materials labeled CFD in parentheses. When selecting CFD fluid materials, you can choose from a variety of fluid property data. For properties, since we are performing a 3D simulation, click 3D first, then move to the 3D CFD tab and add the air material property that we created earlier. Since NFX supports both structural analysis and CFD analysis, it is important to distinguish them carefully and select the correct options. Once the material and property setup is complete, we can now generate the mesh. Since velocity and pressure change significantly around the vehicle, it is recommended to create a finer mesh in this region to achieve more accurate calculations. The feature used for this purpose is called Control Seed. Let's set different division sizes as shown in the video. First, to make line selection easier, let's change the geometry display mode to line. When selecting lines using the Control Seed, be careful not to accidentally select other surrounding lines. For the area around the vehicle, let's set the seed division size to 0.001 meter. Once Control Seed is activated, red dots will appear in the selected region, indicating that the feature has been successfully applied. Next, let's set the seed division size for the outer region of the airflow domain to 0.01 meter. Now that Control Seed is complete, shall we generate the 3D mesh? Click the 3D tab and select the target flow domain. Then, configure the mesh size settings and activate the checkboxes as shown on the screen. After selecting all target regions for mesh generation, make sure that the properties have been correctly assigned. Then, click the arrow on the right and enable geometry proximity and avoid tetra with all boundary nodes to create a higher quality mesh. Now, mesh generation is complete. Let's use the clipping plane to check whether Control Seed has been properly applied. Can you see the difference in mesh size between the area around the vehicle and the outer airflow domain? Now that mesh generation is complete, let's move on to setting the boundary conditions. Let's configure the inlet, outlet, and wall boundary conditions of the flow domain as shown on the screen. Click Inlet/Outlet in the CFD Analysis tab at the top, then define the inlet and outlet separately. For the inlet velocity, enter a value of 2.5. For the outlet, select the surface where air exits and click OK. At this step, when setting the wall boundary conditions, please make sure that only the ground surface and the outer surfaces of the vehicle are included. Next, we will apply pressure boundary conditions to the two side surfaces and the top surface of the flow domain. Once the boundary conditions have been added to the LBC tree on the left, enable mesh visibility on the screen and proceed with monitoring setup. Monitoring is highly recommended because it allows you to output calculated physical quantities from selected nodes, surfaces, or volumes during the simulation analysis. Now, we're almost done. Let's move on to creating and configuring the analysis case. Since this is an external flow analysis, make sure that only fluid flow is checked and verify that an appropriate turbulence model has been selected in the module settings. If you right-click Analysis Case in the Analysis and Result tree on the left, you can see several predefined analysis types. From here, create a steady-state CFD, then click Edit. You will then see an analysis setup window like the one shown on the screen a moment ago. Now, let's start the simulation right away. Once you save the NFX file to your desired location, the simulation will begin shortly. At this step, all the data you have created so far, including the geometry, mesh, and boundary conditions, will be transferred to the solver for calculation. Since the simulation takes a little time to complete, let's fast forward for now. Now that the simulation is complete, let's evaluate convergence using the CFD graph. In general, convergence is considered achieved when the residual values decrease sufficiently and the monitoring values remain stable. However, please keep in mind that you should always verify the actual physical results carefully before making a final judgment. Now that the simulation is complete, shall we take a look at the results? In the Analysis and Result tree on the left, you can review the results for each calculated step. Double-click Total Velocity, then click the Multi-Step Animation Recording button at the bottom to observe contour changes throughout the calculation process. Also, please remember that by clicking the Save button, you can export the results as a video file. If you click Vector in the Result tab at the top, you can also view vector images. In addition, by clicking Flow Path in the Fluid menu at the top, you can freely activate and visualize streamlines. You can freely adjust the number of sampling and line thickness, and you can also control the number of arrows by adjusting the division number. Now, let's take a look at the simulation results we generated earlier. In addition to velocity contours, streamlines, and vectors, we will introduce many more post-processing features through future examples. While following along with today's practice, please make sure to remember these key points. How was today's lecture? Simulation may seem difficult at first, but if you follow the steps and practice hands-on, you can get started with confidence. With MIDAS NFX, learn the fundamentals one step at a time and challenge yourself with a variety of simulation examples. Then, see you again in the next video. This has been Mighty, your hands-on practice assistant.